You know, every time you type a web address into your browser and smack that enter key, you're kicking off this incredible hidden journey across the globe. I mean, it feels instant, right? But behind the scenes, there's this whole complex dance of events happening just to get you where you want to go and to make sure you get there safely. So let's pull back the curtain on that journey.
Seriously, have you ever stopped to think about it? That tiny fraction of a second is just packed with action. Your request doesn't just, magically appear where it's supposed to. Nope. It has to navigate the absolutely massive, complicated network that is the internet.
The easiest way to think about this whole thing as a two-part adventure. First, your browser has to figure out the exact location of the server you're trying to reach. And second, once it gets there, it has to get past the security at the front door.
To really get how we find anything online today, you have to look back at the Stone Age of the internet. Back then, there was just one giant text file called hosts.txt, and everyone had to manually update it with every single computer's address. As you can imagine, once the internet started to grow, this became a complete and total nightmare. It just wasn't going to work. We needed a new system, and that system was the Domain Name System, or DNS.
So what exactly is DNS? The classic analogy is perfect. Think of it as the internet's phone book. See, we remember names, right? Like example.com. But computers, they only understand numbers, these things called IP addresses. DNS is the magic that translates the friendly name you type into the nerdy number the computer actually needs to connect.
And here's how that translation actually works. It's kind of like a detective story. Your computer first asks its local helper, a recursive resolver, for the address. If that resolver doesn't already know, it goes up the chain. It asks a root server, hey, who's in charge of all the .com domains? The root server points it to the right .com server, which then points to the final authoritative server for example.com. That server has the IP address, and this entire multi-step chase happens literally in the blink of an eye.
And boom, just like that, part one of our adventure is complete. DNS has successfully navigated the maze and found the correct digital address. Your request is now standing right at the server's front door. But finding the door? That was only the first challenge. Now for part two. Getting past the guard.
So who is this guard? Well, that's what we call a Web Application Firewall, or a WAF for short. If DNS is the phone book that gets you to the right building, the WAF is the bodyguard standing at the front door. It positions itself between the website and the rest of the internet, and it inspects the content of every single request to make sure it's not something malicious.
So how does this bodyguard decide who gets in and who gets kicked out? Well, it usually works in one of two ways. The first is a block list model. This is like a bouncer at a club who has a watch list of known troublemakers. If you're on the list, you're not getting in. It's pretty good for stopping common attacks, but a brand new threat, one nobody's seen before, it might just slip by. The other way is the allow list model. This is way stricter. Think of it like an exclusive, invitation-only party. If your name isn't on the list, you are not coming in, period. It's incredibly secure, but you do run the risk of accidentally blocking a totally legitimate guest who just wasn't on the list.
And trust me, the kinds of threats this bodyguard is looking for are nasty. We're talking about things like SQL injection, where a hacker tries to sneak database commands into a simple search box to, say, steal all your user data, or cross-site scripting, where they inject malicious code into a web page so that other visitors run it by accident. A WAF is the absolute front line of defense because it's trained to spot the telltale signs of these attacks inside the traffic itself, and it blocks them before they can ever do any damage.
So when you put it all together, you see what's happening, right? You've got these two totally different but essential systems working together in perfect harmony. DNS is the navigator. Its whole job is to find the path through this huge digital world. And the WAF? It's the protector, standing guard at the destination to make sure that anyone who arrives on that path is friendly. Let's just break it down side by side to make it super clear. On one hand, you've got DNS. Its job? Find the correct server. The analogy? The internet's phone book. Its focus is all about navigation and making things accessible. Then on the other hand, you've got the WAF. Its job? Protect that server. The analogy? The application's bodyguard. And its focus is pure security and stopping threats. Two very different missions that come together to create one seamless, secure experience for you. And at the end of the day, this combination of navigation and protection, it's not just some technical detail. It really is the invisible foundation of the modern internet that we all use. It's what allows us to connect quickly, reliably, and with a basic trust that our information and our computers are being protected every single step of the way. Which, it kind of leaves us with a really fascinating question to think about.
We invented DNS to solve the problem of scale, right? And we invented WAFs to solve the problem of application security. So as our digital world gets more and more complex, what new problems are we going to face? And what do you think the next invisible shield we invent will be?